pleasure to present the pre-recorded talk of Erika Marques Santana from the University of Sao Paulo in Brazil. She will talk about pre-maturation social experience and female preference function in crickets. Remember, after the talk, Erika Marques will be able to reply any question you post on the YouTube channel or later on the Discord platform. Welcome, Erika.
Hi, everyone. My name is Erika, and I'm a researcher from Brazil. I finished my PhD in 2018, and here I will show you the results of a work that it's a follow-up of part of my PhD research. I carried out this work with Danilo, an amazing friend and colleague, and the title of this presentation is Does the pre-maturation social experience affect female preference function in Teleogryllus commodus? Well, it's highly established that the potential that mate choice has in promoting the evolution of elaborate traits in the chosen sex. Here we have several amazing examples of traits that evolved by mate choice. However, mate choice itself is a trait expressed by the chooser sex and is a trait that determines the form and the intensity of the selective pressure that will act on the chosen sex. The way we measure mate choice is by the preference function. Preference function emerges from the chooser response to chosen values. Here we have a preference function generated by females' mating probability that is homogeneous in an hypothetical population. In this case, all females present a higher probability to mate with males that present intermediate values of the chosen trait. However, this is not always the case. As any trait, mate choice is not always a fixed trait between the choosers. The preference function can show different forms as belly-shaped, as here, sigmoid-shaped, or even linear shape. These functions can also present different slopes, as we see here in these belly-shaped functions. And these slopes is theoretically defined as the strength of the mate choice. Finally, different individuals or groups of individuals in a population can present different preference functions in which they will impose different peaks of these preference functions, as here, in which they will impose different selective pressures on traits presented by the chosen sex. Finally, adult traits can be adjusted based on the social cues they experience as juveniles, as in all of these examples here. Also, and including mating preference, as in this example. However, the importance of juvenile social environment on the preference function expressed by adults is still a poorly explored topic. With this in mind, our aim here was answer the following question. Does the acoustic environment experienced by juvenile females affect adult females' preference function? And we hypothesized that females raised in environments with varying quality of male sinus will present greater variation in mate preference as adults than females raised in environments with homogeneous male signals. To test our hypothesis, we choose the cricket Teleogryllus commodus as our model species. Females of this cricket are highly polyandrous, do not gain any material benefits of mating via male's spermatophore, as you can see here, a female with male's spermatophore attached on her, and these females choose males criteriolously according the male calls. What defines a male call as attractive for a female of this species is the length of interval between the trials of the call. So, the shorter the time interval will be, the greater will the effort to call for the male, and the more attractive the male will be two females. So we recorded 3 empirical male calls, 1 highly attractive male call, 1 call with intermediate attractivity, and 1 call with low attractivity. With these calls, we composed 2 experimental acoustic environments, each of one composed with 3 male calls, and this environment simulates a social environment for these crickets. Here we have the 2 compositions. The experiment for males in this population we have in the lab were randomly directed to one of these 2 experimental environments. In the high experimental environments, we composed a song with 3 high attractivity male calls. In the mixed male attractivity environment, we call the mix, we composed a song with 1 of each kind of male call according to the attractivity of the male call. And each experimental group was kept in a different room. Juvenile females were kept in individual containers placed in the center of these calling boxes. And females were kept in experimental rooms since their molt to the last instar before maturation until being used in your mating trials already as adults. Experimental females were then presented to 10 different males sequentially, and we recorded the acceptance or rejection by females. We also recorded the calls emitted by the experimental males during their whole lifetime, and used the average, the mean calling effort of each of these males as an indicator of male attractivity. And to analyze our data, we used generalized linear mixed models with mating as our response variable and mean calling effort, number of mating trial or order of presentation, the position of if it was the first, the second, or the third, and so on mating trial, and the female group, high or mix. And also the number of mating trial here should be the same name, is interaction between order of presentation and female group. We choose the best model through the AYC model selection, and we also included mixed effects considering the identity of females and males. This is our first result. We found that the probability of females accepted to mate decreases along mate trials, but only for females heard in a variable quality environment. We confirmed also that females present higher mating probability according the male attractivity, high male attractivity. But we do not find differences in the preference function showed by experimental females. Here's the preference function, and was the same between the groups. So our hypothesis was refused. However, we then decided to explore how female preference varies between experimental females and experimental groups. We estimated the uncertainty of the empirical female preference values and by generating confidence intervals for mean preference values and for standard deviation preference values. And how we did this? We used a bootstrap technique. We took our empirical data, resampled the values with replacement in your table, took this new data and fitted our model, which I explained earlier, and recorded the coefficients of this model, recording the values of the mean and standard deviation of female preference. We did this 5,000 times, and thus we get a distribution of the uncertainty of the values for the mean and for the standard deviation of female preference. Here's the first results. This curve represents our certainty about the mean preference shown by females. Again, there is no difference between our experimental groups The both curves is near -2, just saying that these values of male attractivity are scaled, and that means that there is a peak of female preference here around this point, and is below most of the values of male traits. Here in gray we have the distribution of the empirical values we found of male attractivity, and most of the values, the male values and male trait values, are above the preference peak presented by females. Also, we do not find differences in the curves of uncertainty for standard deviation of these females. Here you have both curves. Again, these curves are above the point in which we mark the standard deviation found for male calling effort, our chosen trait. And so females present higher variation in their preference than the variation presented by males in their trait. So our conclusions and discussion based on these results are the consequences of these results is that as the mean female preference is below mean male trait, most males have a high probability of mating. Also, there is a higher variation in female preference than in the male trait, so matings probably don't concentrate in few females. And in conclusion, selection on male calling effort is probably weak, and variation in female preference may maintain high variation in the population of male traits, as was pointed by the model elaborated by Milan and collaborators last year. Thus, we believe that these cricket females are doing a bet-hedging strategy in which they will exert relatively weak pre-copulatory mate choice, copulate with several males, and perform stronger post-copulatory mate choice, an established advantageous strategy presented by polyandrous females. This conclusion is confirmed when we considered the results I found during my PhD, achieved through the same experiment design and same species. We have found that females reduce the time they retain male spermatophore after mating, according the number of mating opportunities increase. But this reduction rate is higher on females from the mixed group. And mainly, females produce heavier offspring when have mated with more attractive males, but only females heard in the mixed treatment. That is, the social environment that females experience as juveniles determines how adult females direct their investment in offspring in response to male quality. Based on all the points I have made so far, these are our take-home messages. Females vary a lot in what they want. Female mate choice may only cause weak pre-copulatory sexual selection. As female copulate with many males, post-copulatory sexual selection should be strong. Social environment has only weak effects on pre-copulatory process as mate choice, but can be important to post-copulatory process, at least in this species. And now I want to thank the Instituto of Biosciences, Bioscience Institute of the University of São Paulo, Universidade de São Paulo, where I did my PhD. Thank to Laje, our big and amazing lab. Thank to Glauco Machado, my PhD supervisor, for all the support during my PhD. I want also thank to Michael Kazumovic from Australia. Was in his lab that I conducted all the cricket experiments I did here and I described here. I need to thank also thank Michael for accepting me and for the support. I also want to thank the CAPES, the funding agency, for funding both my PhD in Brazil and my internship in Australia. And finally, I want to thank Danilo for accepting the invitation to work with me on this idea that was originated during the pandemic. If you guys want to follow my work or contact me, you have these options here, my website, my Twitter, my 2 emails. Here you have a couple of these crickets mating that are so cute. And thank you for your attention.
Thank you very much, Erika. Now let's see, we have a question in the YouTube channel. So the question is from Abby George, and it says, great talk and experiment. Do you think the age of females has an effect on the variation in preference? Example, would your results change if you had used females younger than the later instar ones?
Thank you for your question, and thank you for the accomplishment. These females live a really short life. Most of the females died 1 month after become adults. And to the last paper that I published last year, we did analysis with controlling by the days. We used the days after adulthood as age, and we used these values as predictors in our analysis, and we didn't find any effect. In this analysis of preference, our models, when we compared them, there are a lot of parameters. So if you use a lot of models, a lot of combinations, the results, the A, Y, C, are a little bit confusing. A lot of models like similar. So we didn't use it because we tried before and doesn't seem to be important. But as I told, these females live really shorter, so I don't think it's enough for them. And also we controlled for other points as mass and length of these females. So we believe this is not important for these females. But thank you. Great question.
Okay. I have a question, Erika. I remember that you said at the beginning that for this species, the character that makes them more attractive or not is in the acoustic profile of males. So I wonder if they are able to change this acoustic profile along their lives, or if it varies or not.
I'm not sure. I guess there are a lot of information published about this cricket. I guess I read before that older males so much older males become less attractive sometimes because calling efforts like it's really expensive for them. Keep doing a lot of trials, so this is slowing this trait a long time. And in the beginning of their life, they like the first and second day, based on my experiments, they do not call a lot, but seems to be determinant as for each male, more than I experience for these males as like a trait particular for the male. So, but we controlled, but also about this for these traits for these males as size, mass, length, age, order, and you use it male as a mixed effect by itself. So we believe it's not important for these results also, but yes, could be important. And great question, thank you.
And for example, I have another one. Were you recording the male's call and then you just took one part of the recording and then show it? Expose it to the
For the choice, the males could mate with them. So we have a lot of males. Any male that becomes adult, we put in a box with a microwave, and they stay there. It stay there all his life. And we just take take him off to use in mate trials. So we put females are in a box, like a small box, alone, and I put the male and make them solve themselves. I establish a time to the insert of the female based in some pilot experiments, and I release them. She can mate, she can avoid, and he keep singing or trying to approach her. And it's funny because if she don't want, she kick him, and she needs to clean. Females of this species have to stay up the male, so it's almost impossible for males to force copulation. This is important because if it's not like this, sometimes there are a lot of species that males can force or coerce females. In this kind, it's impossible. And this species is impossible. So after this period, we take male off and put again on the calling box to keep being recording. And the data of these males, we have the amount of calling with the number of trials for each day during their whole life. So we calculated the mean of each male per hours recorded. We have to organize this data and make the calculus to have a one mean for each male, because we have a lot of days, a lot of hours. I have to remove the day I use because there are my own song, like manipulating the box. But it was like this. We have one mean value for each male, and previous papers with this species have shown that this mean, this average for males is really important for female choice in this species. So I used also this information.
Thank you very much. That was a great talk.
Thank